Hello, mic test.
Hello, mic test. Hello. Hello, mic test.
Hello.
Morning everyone. Antay lang tayo ng konti. Mga 9:05. Start na tayo. Bale may sesend ako sa GC na file ng data na gagamitin natin ngayon. If ever ma-download nyo para at least makita nyo. Nasaan ko na yung file. Please na lang. Download na lang and check. And I hope some of you na download yung application o yung software na Pom-Qm para at least during the discussion is ma-try din natin. Ma-try nyo. Okay, good morning everyone. Let's start our discussion. So, bago pa lang lahat, dun sa sinend ko na grades for your midterm, if you have any other question, don't hesitate to approach me or send me a message. And then, dun sa kulang pa yung requirement or yung activity, please pa-send na lang. Antay ko naman siya. Bale, isa na lang yung nantay ko for the computer application na activity. Isa na lang yung may kulang. Okay? So, let's start. So, based on our first half ng ating first sem, so mostly, nachinika ko yung papel nyo sa activity nyo about graph and dun sa midterm, medyo hirap pa rin on how we construct yung graph natin. So, let's try lang na daanan ko lang siya na mabilis. So here in dun sa activity 2 na hindi, wag dito sa 2. Dun sa ating sorry. Sa midterm natin na sorry, hindi ko na makita yung data. Anyway, mostly nang chinecheck ko doon sa graph na ginagawa natin is yung completion ng elements. Tapos, ano ba yung pipiliin natin na graph? Kung column bar graph ba siya or line graph? So, mostly ay kapag line graph, kapag time series, merong line tayong ginagamit. Pero kung hindi naman siya time series, for example, based dun sa model or based sa color, hindi natin kailangan lagyan na siya ng line wherein dot lang for the total. So mostly yun yung nagiging problem natin dun sa graph. But all in all naman okay. Okay po. So let's start our discussion with our new software na mostly ginagamit ng IE, which is the Pom-Qm. Na-download yun ba yung software?
Opo, sir.
Okay, may nakapag-download naman Sige. Let's start lang brief discussion lang what is Pom-Qm. So Pom-Qm is a software package to help solve problems in the fields of operations management, production, operations research, management science, and quantitative method. It is also known as production operations management for Windows and quantitative methods. So kaya siya tinawag na Pom-Qm. So this software enables users to find solution to data analysis problems or check the authenticity of answers derived by solving the problems manually. So most of our problem solving tasks na manually na ginagamit natin as industrial engineers, yung dinaanan natin sa ating operations research, method study. Actually, this Pom-Qm, pwede niyang gawin to using the software. So students taking various courses in statistics often find difficult dealing with Pom-Qm assignments due to the complex nature of underlying concepts. So for the features of Pom-Qm, later papakita natin yung details ng Pom-Qm. So first, it is Pom-Qm for Windows comes with impressive features that makes it possible for data scientists to perform effective and efficient analysis. First is the standardization. So Pom-Qm is no different from the standard Windows interface. So if you're already familiar with the normal Windows spreadsheet, presentation package, o word processor, almost same siya. So mas madali siyang intindihin. Although the software package contains 26 modules and over 50 sub-modules, the screens for all modules are the same. This means if you're familiar with the one module, then it will not be difficult for us to work with other modules. Also, storing and retrieving files in Pom-Qm is quite simple. If you save the file, the data, you can easily access those po. The next one is flexibility. So the user of Pom-Qm, it provides you several preferences that you can use to customize your working area. So for instance, you can set the application to save your files or solve problems automatically. Once you have entered data in the worksheet and one click, the problem will be solved. User-friendly interface. So sabi nga, it is spreadsheet-like data editor na mas madali natin may edit yung data. Moreover, every time you enter data, the software displays clear instruction on what you ought to do next. Kasi every module na meron doon sa Pom-Qm, meron tayong makikitang mga notes kung ano yung ilalagay natin, ano yung input natin data. And then the program group, when the software is installed, it adds program group to the start menu. The program group contains 4 items: the normal distribution calculator, Pom-Qm for Windows for help, Pom-Qm for Windows, and Prentice Hold website gateway. So, once you open, pag binuksan yung Pom-Qm, merong 4 na program group tayong makikita. So, the significance of Pom-Qm for Windows in academe, it is an effective tool in academic. Hence, mostly na tinuturo sa atin talaga sa school is the manual problem solving, which is better na mas maintindihan talaga natin siya before we are going to use this application. So for students, it made it easier to perform mathematical operations. For professor, Pom-Qm for Windows can be used to develop professional skills needed for teaching and improving the learning in classroom and lecture halls. While for the institutions, so it can be used to store and retrieve students' information, course information, and other records that are essential to the institution. So yan yung brief discussion or brief description ng ating Pom-Qm application. So the Pom-Qm application will take 2 session para ma-discuss natin lahat. Pero hindi lahat ng modules is i-discuss natin. Siguro yung common lang na ginagamit natin as industrial engineers yung i-discuss ko. Okay? So possible for the next meeting natin ay mag-video na lang ako using the application, or if wala naman akong masyadong plan naman pasok na Saturday, we can meet through Zoom pa rin. Para mas maturo natin siya ng actual. Okay? So let's open our Pom-Qm. And the data na gagamitin natin ngayon is sinend ko dun sa GC natin. Please browse na lang kasi yun yung gagamitin natin. So you can try to use the Pom-Qm using those data. Okay? So let me share my screen for Pom-Qm. Okay. So this is the Pom-Qm for Windows. So as you can see, sabi nga, common siya ng interface pagdating kay Office, Microsoft Office, kay Word, kay Excel. So makikita lang natin dito yung mga tabs. And then, on the left side of the screen, these are the module 3. This is the module 3 which composed of 26 modules and 50 sub-modules na kung saan pwede natin gawin kay Pom-Qm. Okay? So we have here the aggregate planning, assembly line balancing, assignment, break-even cost volume analysis, decision analysis, factor rating, forecasting, game theory, goal programming, inventory, layout, learning curve, linear programming, location analysis, Markov analysis, material requirements planning, the network and the productivity, the project management or the PERT CPM, the quality control, so reliability, statistics, and then, so kung makikita nyo, meron ditong mga sub-modules tayong makikita. So for aggregate planning, meron diyang aggregate planning and then transportation model. For decision analysis, meron tayong table, decision trees, factor rating. Sa forecasting, yung type of forecasting method natin is nandito rin lahat. Inventory, the EOQ, the quantity discount model, the ABC analysis, the reorder point, learning curve, the network, the PERT CPM, quality control, the P chart, X chart, C chart. Sabi ko nga, lahat halos ng sinosolve natin manually is nandito kay Pom-Qm. So, mas madali natin masosolve yung problem using this software. Okay? So, let's start. Open natin yung ating data. First natin, so nag-start na ako kay assembly line balancing. Kita nyo ba yung data natin? Hindi ko lang share ko lang yung data. So we have here the data, the example of assembly line balancing. An assembly consists of the following elements as given in the table below. So we have here the task, the immediate predecessor, and the task time. So the production rate is required one assembly every 15 minutes. Kailangan daw makapag-assembly tayo in 15 minutes ng isang unit. So determine the minimum number of workstation required so as to minimize the balance delay. Find the balance delay station-wise and doon sa ating precedence diagram. Okay? So let's try to input yung ating data. So yung data, buksan nyo na lang sa inyo para mas makita natin. Okay. So what we are going to do is click the assembly line balancing. So may magpa-pop up na window which is we have to provide the number of tasks na meron tayo. So based dun sa ating example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tasks. We have 12 tasks and we can change the row names into letters, small letters, task 1, task 2. So based on our example, it is ABCD. So we are going to use ABCD and then time unit for task is minutes based on our example. And then we have to click OK. So after we click OK, lalabas dyan yung table kung saan i-input natin yung data natin. Okay? So we have here the task A, B, C, D, E, F, G, task A to L, and then the minutes. So we have to input here the minutes of the task time. This one is 12, 6, 6, 2, 2, 12, 7, 5, 1, 4, 6, 7. So this is the task time in minutes and then the predecessor which means ano yung susunod na process sa kanya. So we have here kung ano yung ilagay nating task name dito, yun yung ilalagay natin dapat dito. So kung ang nilagay natin dito is 1, 2, 3, ang ilalagay dapat natin dito for predecessor is 1 or 2 or 3. Since AB letter yung nilagay natin, so yun din yung ilalagay natin dito kay predecessor. Okay, for task A, wala. Task B, we have task A. For task C, B. For task D, B din. Task E, B. Task F is B. Task G is C and D. So kung dalawa siya, we have to input C dun sa predecessor 1 and D dun sa predecessor 2. For letter H, we have G, I, E, J is I and F, K is H and J, and L is K. Okay? So we have here data we needed. We have here the method and the cycle time computation. So based dun sa ating problem, we have meron na tayong required production rate which is 1 assembly every 15 minutes. Okay? So, computed yung ating cycle time. Ilang units daw? 1 for every 15 minutes. So, yan yung ating cycle time computation. So, we have here also the method. Actually, based on our problem, walang method na nakalagay. But for assembly line balancing kasi meron tayong iba't ibang method. We have the longest operation time, most following tasks, rank positional weight, shortest operation time, and the fewest following tasks. So for this problem, we are going to use the longest operation time. Later on, try natin yung ibang method. Okay? So after natin ma-input lahat ng data, we just have to click solve. Once we click the solve button, we can see here the result that the minimum number of station is 5. However, the actual number station of 6. Time allocated per cycle time is 90 minutes per cycle. Time needed to finish some of tasks is 70 minutes, and the idle time is 20 minutes, wherein the efficiency is 77.78%, wherein the balance or the delay or the 1 minus efficiency is 22.22%. So for this one, may kukumpute agad natin what is the efficiency of the assembly line. So if we are going to check or verify yung ating graph, we can click the solution button here and then graph. As you can see, based on our problem given, same siya ng graph na na-produce. Okay? So same siya ng graph dito. So what if we are going to edit data, change our method, tingnan natin kung magkakaroon ng pagbabago doon sa ating efficiency. So we have the most following tasks and then click solve. Ganun lang din, walang pagbabago doon sa ating efficiency. The number of stations is andun din, as well as the graph. Rank positional weight, shortest operation time. So sa shortest operation time, doon tayo nagkaroon ng changes sa ating efficiency, which is 66.67%, wherein yung idle natin is 33.33%. Okay? And the fewest following tasks ay same din nung kanina, the 77.78%. Okay? So we have here also the summary of heuristic results. Ito yung summary, longest operation. Doon sa mga method na meron tayo, pinakita doon ano yung mga number of stations. So for longest operation time, we have 6, most following task is 6, rank positional weight is 6, shortest operation time 7, and the fewest following task is 6. So dito, nagkakaroon na ng summary yung ating problem. Sorry, mahangin. Wait lang. Okay, sorry. So yun. So yun yung ating module 1, which is the assembly line balancing. Okay. Do you have any question with assembly line balancing? So kung wala na, let's proceed to the next module, which is the assignment problem. So sa assignment problem, ginawa natin siya dati kay OR. Hindi ako nagkakamali. So operations research. Or the assignment of job. So we have here our problem. For the assignment problem, so ang kailangan lang natin is ma-maximize yung ating workers dun sa job na meron tayo. So we have here our problem. These are the workers, worker A, B, C, D, and the job 1, 2, 3, 4, and 5. And the number of units a worker to finish the job. Okay? So, balik tayo kay Pom-Qm. Click lang natin si assignment problem, and then lalabas ulit yung window. Input lang natin the number of job, which is 4, and the number of machines, syempre same with our other jobs. What we are going to do is to maximize yung
Sir, excuse po.
Yes po.
Wala pa po yung...
Sorry.
Thank you po.
Ay, no problem. Okay. So, ulitin lang natin. So, gagawin lang natin, click lang natin si assignment dun sa ating module 3. And then, the number of job is 4. And our objective is to maximize yung job na meron tayo or para ma-maximize natin yung number of units na magawa ng ating mga workers. So, for the row names, this is job 1, 2, 3, and for the column name, I, C, A, B, C, D based dun sa ating given. Okay? And then click OK. So, we have here, kung makapansin nyo, baliktad siya doon sa ating given na meron. So, let's try to input lang yung ating given. Okay. So, type lang natin 9, 2, 7, 8, 4B, 6, 4, 3, 7. Yung data natin medyo baliktad kasi yung ang nasa column kasi natin kanina is yung sa given is job, for the row ay yung worker. So dito baliktad. Job yung nasa row, worker yung nasa column. So C is 5, 8, 1, 8. And for D, 7, 6, 9, 4. So, click lang natin yung maximize and then after natin ma-finish yung data, inputin ng data, click natin yung solve. So, as we can see here, we can maximize the number of unit or the optimal solution natin is 33 yung kayang gawin nila for a day. If A will be assigned to job 1, B will be assigned to job 4, C will be assigned to job 2, and D will be assigned to job 3. So for these solutions, we can have an optimal solution value of 33 yung kaya nating i-produce. Another example is we are going to minimize. For example, ito naman ay task time na pwede gawin. For example, itong job na to is the number of time allotted para matapos yung isang job. So, edit natin yung data, minimize, and then click solve. So, dito naman, it means ang optimal solution value natin is 13 wherein si A, i-assign natin kay job 2 kasi 2 minutes lang niya, or for example, 2 minutes lang niya matatapos yung job. Si B naman ay kay 6, si C ay kay 1, and D ay kay 4. So, kung ginamit natin siya kung ma-manual natin siya, medyo matatagalan tayo. But for Pom-Qm, so mas madali natin na-assign yung mga job na meron tayo per worker. Okay? So we have here the marginal cost and the assignment list o yung pinaka-summary ano yung magiging assignment list natin. Okay? So maximize lang natin ulit. Mas makikita natin yung assignment list and the optimal solution value which is 33. Okay? So next, our next problem is the break-even analysis. So we are trying to find on what quantity of product or units na mabenta natin na kung saan mababawi natin yung ating fixed cost and the variable cost. So we have here the given. The variable cost is 7 per unit. The price is 12.50 and the fixed cost is 100,000. So dito meron ng given answer which is 18,182 units yung ating break-even unit. So try natin siyang ilagay kay Pom-Qm. So click lang natin si break-even analysis. Doon tayo kay break-even analysis cost versus revenue. Okay? So we have here the fixed cost. Ang fixed cost natin based sa problem ay 100,000. Tama na ba? And the variable cost is 7. While the revenue per unit is 12.50. Then we have to click solve. So based dito, same with our problem, our break-even point in number of units is 18,182, or in terms of cost, or in terms of revenue, cost versus revenue, we have $227,274. Okay? So, we can use other break-even cost volume analysis, which is wherein meron tayong mga break-even problem na kung saan there are different number of costs and different number of options. Ito very rare naman yung yung mga ganitong problem, but for example here we have there are two costs, there are two cost type. Okay? So, try lang natin the fixed cost is 100,000 and this one is 150. And then for the variable cost for each is 5 and 7. So wala tayong makikitang break-even point kasi mayroon tayong kulang dito na data. Hindi kasi nagtagma. Sorry, hindi ko na pati yung graph. Dito, dun sa ating dalawang cost in terms of volume, hindi nagtugma yung dalawang graph natin. So, let's try to edit yung data. Gawin natin 12 to. Yan. So, magkakaroon tayo ng break-even point na kung saan once na mag-cross over yung both graph, yun yung ating magiging break-even point, which is in 10,000 volume. Okay? In terms of multi-product, so multi-product naman, talaga lang dito number of items. Kumbaga, marami tayong items na binebenta, ilan yung magiging break-even point natin in terms of price, cost, and the forecast. Ito medyo mahirap kasi meron tayong forecast kung ilan yung possible nating mabenta. Okay? So, kaya hindi ko na siya binigyan ng example. An example na lang is the break-even analysis, which is the cost versus revenue, which is ito yung ating common. Okay? Our next module is the decision analysis, which is the decision table, wherein ito ginagamit natin to in order to find the maximax, the maximin, or the minimax regret. So we have here the example. We have here the three alternatives and three payoff status. We have the growing, stable, and declining, the bonds, the stocks, and the mutual funds. So let's try to use the Pom-Qm. So we have here the decision analysis and decision table. So papapulit yung windows. Tingnan natin ilan na number of decisions. We have 3. And the number of nature states is also 3. So based on our problem, we are going to maximize kung saan ba tayo mas kikita or yung profit natin. Okay? So we have here the decision, probabilities, and the payoff table. Okay, so we have here the decision 1. We can change yung name ng decision natin based on sa given. So we have bonds, stocks, and mutual fund. Bonds, stocks, and mutual funds. Pwede natin siyang baguhin based dun sa problem na meron tayo. So we have here the payoff table, the growing, stable, and the declining. For the bonds, we have 40, 45, and 5. 70, 30, and negative 13. For mutual funds, 53, 45, and negative 5. So, as we can see, sorry na enter ko na. Once pa kasi ma-enter natin yung data, automatic na labas na yung result. Pero kung manual natin, click lang natin si solve natin data. Okay? So, we have here the result of our decision table wherein the maximum is 5 given by the bonds. Sabihin, in terms of maximax decision, we are going to select to invest in bonds, while for the maximax stocks pala, sorry. For the stocks is 70, while for the maximin is the 5. Okay? So, ang pipili naman natin is the bonds. Okay? So, mas madali natin siyang ma-compute. Okay po. So, this is the decision table. And the minimax regret is 17. Kung ito, manual natin kinocompute dati. So, ito, mas madali natin siya makikita. This is the minimax regret. And ito, I don't know kung ituro ba sa atin yung Hurwicks table. Kapag may value, pero alam ko parang may example ako nito eh. Wala. Hurwicks value, pag mayroong given na Hurwicks value, ito yung possible maging result or maging paano ba? Dito tayo mamimili kung ano yung magiging decision na pipiliin natin. For example, if the Hurwicks value is 0.6, lumalabas dito na 36.8 yung ating magiging maximax, which is stocks yung pipiliin natin. But for example, sa in terms of 0.19 Hurwicks values, ang pipiliin naman natin is the bonds. Okay? So, yan. So, next module is the decision trees. Yan. So, parang same lang siya ng problem kanina. Okay. So, this one is the decision trees. Ito, manual natin gagawin to. Okay. So, let's try to input the data on our Pom-Qm software. So, the QM for Windows. Click lang natin decision trees. And, syempre, ang ating objective pa rin is to maximize. Yan. So, kung mapapansin nyo, iba siya doon sa ibang module. Nagkakaroon tayo dito ng, magpo-provide tayo dito ng tree mismo based doon sa ating problem. Okay? So, we have here the select node. Sinelect natin si 1. Ilan yung branch na meron tayo based doon sa problem natin? We have 3. The stocks, the mutual fund, and the bond. So, we have the number of branches is 3. And then, add and branch. Okay? So, mapapansin nyo, we have 3 decision. So, let's try to edit lang yung ating wala. Yan. Try natin palitan yung pangalan. Click lang natin yung decision 1 and then data for branch 1, 2 stocks for decision 2 ayaw maklik yan. Mutual fund for decision 3 ay bonds. Okay. So we have here the 3 branch dun sa ating first node. Okay? So doon sa ating bonds, meron na siyang value which is 20. Palitan lang natin yung profit dito. Tapos lagyan. Okay? And then for the stocks and mutual funds, so based on sa ating problem, meron pa siyang tigda-dalawang branch, which is the growing and declining. So ang gagawin lang natin, click lang natin ulit si node number 2, add branch tayo na dalawa, add and branch. Yan. So we have here the event 1 and the event 2. For event 1, this one is growing. Palitan lang natin. Dito sa ating data for branch 2-5. And yung ating probability based sa problem natin is 0.4. The profit ay 70. Next one for event 2, declining. probability is 0.6, and profit ay negative 13. Then for mutual fund, add lang ulit tayo ng dalawang branch. Lagay lang natin dito number of branches and then add end branches. Edit lang ulit natin yung name. Growing. Probability niya ay 53. 0.4. Profit niya ay 53. For bent 4, declining. Probability of 0.6 and profit of negative 5. Lagyan lang natin ng dollar sign. Ayan. So, yan yung ating decision tree based doon sa ating problem. Okay? So, after natin okay. After natin ma-input lahat ng data or mag-draw yung ating decision trees, click lang ulit natin si solve. Yan. So based doon sa ating solution, makikita natin the expected money value ng ating decision is $20.2. So ano yung pipiliin natin? We have to choose yung stocks. Ito. Yun yung naka-blue na, naka-highlight ng blue. Okay? So, as you can see, for mutual funds, $18.2 lang yung expected natin. And then for the bonds is $20. So, what we are going to do, what we're going to choose to invest is we have to invest in stocks. So, ito, nagbabago-bago siya. Siyempre, depende dun sa ating data. So, for example, if we try to edit yung data natin, pagta natin yung bonds ng 22, and solve natin yung data, magbabago yung ating solution. So, we have to choose yung bonds natin, which is $22. Okay? Kung dati, kinocompute natin siya ngayon, ganito na. Mas madali. Okay? Any question? Kung cost naman, for example, cost yung data nito, syempre, ang pipiliin niya is ano yung pinakamababa, which is the mutual fund, $18.2. Okay? So, yun lang. Next natin ay single period inventory level. May question ba kayo? Or bibilisan ba kayo? Hindi naman. Okay, let's proceed to single period inventory level. So we have here the problem. We have the demand, the probability, and the P, and less than X. Okay? So, the selling price, SP cost per price, salvage value SV, the cost of understocking is $12, and the cost of overstocking is $6. So, try natin siyang input kay Pom-Qm. So, the single period model, the number of demand based on sa ating problem ay 1, 2, 3, 4, and 5. Then, click natin si, okay. So, we have here value, probability distribution value 1, 2, 3, 4, 5. Demand natin, 80, 90, 100, 110, and 120. Probability natin, 0.20, 0.25, 0.30, 0.15, 0.10. Sorry, na-enter ko ulit. So, yan. So, once na mali yung input natin data, for example, ginawa natin itong 0.15, sinolve natin, it cannot be solved kasi yung probabilities, sum ng probabilities ay more than 1. So, kailangan more than, equal to 1 lang siya. Okay? Yan, so 0.1. So, So based on sa ating problem, the cost of understocking or yung and the cost of overstocking or yung sa excess is $6. So try natin ilagay ito si profit per unit excess is 6 and the profit per unit wala pa lang nakalagay dito. The selling price wala nakalagay. So we have to click solve. So we have here the maximum is 0 given by order 80 and the maximum is 240 given by 120. So if ever we are going to choose yung ano yung pipili natin if we are going to use maximax decision, so we are going to order 120 units, but if we are going to use maximum decision, we have to use the 80. Bakit walang sorry, ulitin natin yung data. Tama, 80. Okay. So yun. So we are going to use the 80 for the maximum and the maximax for $120. So ganun lang kadali kapag single period model. Okay. Next natin ay factor rating model. Actually, yung factor rating model para siyang location analysis problem. So we have here the factors 1, 2, 3, 4, the weight, and ano yung mga choices natin, Barclay or Chester. Okay, so try natin siyang input sa ating Pom-Qm. Ay, sorry. So factor rating, number of criterions natin kanina is 4 and number of option is 2. Yung criteria 1, pwede rin natin siyang palitan ng pangalan. For example, yung una lang, average community income. Next, community growth potential. Availability of public transport and labor costs. For the weights, nandun yung given, 0.3, 0.2, 0.2, and 0.3. So for the 100-point scale, we have 57 Barclay and Chester. Palitan din natin. Barclay ay 50, 70, 90, and 20. Naman ay 30, 40, 80, 80, 30. And then, kapag kompleto na yung data, we have to click solve. And then, lalabas that weighted total average is 57 for B and 57 for A. So if we are going to choose, anong pipiliin natin using our factors is dun tayo kay B, kay Chester. Okay, ganun lang kadali. Parang location analysis lang yung ating factor rating. Wait lang guys Okay, let's proceed to our next module. We have here the forecasting. Yan, sa forecasting, marami tayong mga sub-modules. So we have the time series analysis, least square simple multiple regression projector, and the error analysis. So let's try muna yung time series analysis. So based na sa ating problem, time series natin is from 2000 to 2020. So ilan to? 1, 2, 3, 4, So, 21. Naman pala. 21 yung ating past periods. Click lang natin si okay. So we have here the past period and demand. Para hindi tayo, sorry, hindi pala kita, sorry. Kita niyo ba? Ayan, sorry. So click lang natin si time series and then doon tayo kay past periods natin is 21. Click natin si okay. So for the past period, mas madali i-copy na lang natin. Pwede natin siya i-copy paste kung marami talaga tayong data ang kailangan i-input. No need natin siyang i-manual. So from 2000 to 2020, we're in the demand ay ito. Kakapi lang din natin. So we have here the demand Y. We have here different method, the naive, moving average. So try natin i-solve. For the next period is 263,582 using naive method. Ito yung details, error, yun yung magiging computation. Graph, forecasted. So if you're going to use other method, for example, the moving average. Sa moving average, meron tayong magiging question, ilang periods ang kailangan natin i-average. So try natin 5. Solve lang din natin. Next period will be 250,175.2. Makikita rin natin ito yung details and analysis error, solution, the graph. So yan yung blue natin is the forecasted. Okay. Then we have here also weighted moving average. Sa weighted moving average, nagkakaroon tayo ng weight most recent period. Ito. 3. Pagkakas natin ito. 0.2. 0.3 and 0.2. Ayan. So, solve lang natin. Mag-iba rin yung ating forecasted forecast demand for the next period. So, we have it 249. We have also here the exponential smoothing. Well, yung alpha, minsan binibigay natin yan. May given sa problem. Exponential smoothing with trend. Simple linear regression. Least squares. Multiple active user defined or the error analysis. Okay? So, yan yung different types of time series analysis na ginagamit natin kay Pom-Qm. Next natin is least square and simple. Least square, simple, and multiple. So we have here the data of our least square, multiple, and simple. Number of batches 7, number of bottles, and the term in terms of cost. So try natin siyang ilagay kay Pom-Qm. Least square, simple, and method, simple and multiple regression. So the number of observation is 7, and the number of independent variables is 1. So for the observation 1, the dependent variables is 4,100, 36, 32, 2860, 1950, 1020, and 580. We're in our cost is 66,000, 53,000, 2,100, 48,320, 36,750, 33, and 17,000. So, yun. Ayan. Pag, once natin ma-input yung data, lalabas dito yung regression line nung ating problem, which is y equals negative 1,033.968 plus 0.08 times b, wherein the correlation coefficient is 0.972, the coefficient of determination r squared is 0.942. The mean absolute deviation is 214.166. The mean squared error, standard error, the mean absolute percent error, lalabas lahat dito, mas madali. The ANOVA summary, andito din. So, kanina pa to. And then the graph ay lumabas. The sum of squares computation. So yan. So nandiyan lahat yung ating nangyaring computation. Okay? Okay. So let's move on to our next module. Which is the regression projector. So is this our data? Is statistics extra practice with linear regression? Does a person's muscle mass decrease with age? Using your graph, okay. Sige. Basta ito yung data natin. Let's try to input sa ating Pom-Qm. So, click lang natin si regression projector. Independent number of forecast natin ay 16. Number of independent variables ay isa. Kasi yung isa ay dependent variable. Okay? Okay. Bakit? Nag-iba. 21. We have here the, sorry, dalawa pala. The X1, input lang natin lahat yung data. Baba 21, sala pala. Cancel. Ulitin natin. Ilan ba to? 16 lang pala, 16. Tapos, dalawang independent variable. Two, 82, 71, 91, 64, 143, 68, 67, 87, 56, 73, 78, 68, 80, 56, 65, 76, 84 and 65, 116 and 45, 76 and 58, 97 and 45, 153, 105, 49, and 77, 78. And then, solve lang natin yung data. Sorry. Walang lumabas dun sa forecast. So, using your graph paper, plot these on a sketch and identify the points that represent age 71 and mass muscle is 82. Tayo natin ilagay dun sa coefficient. Yan. So, lalabas yung forecast dun sa ating dun sa solutions natin. Okay? So, yun. And then, for the error analysis naman, ito, parang kinocompute lang natin based dun sa forecast natin at based dun sa actual na naging result, ano yung naging error, anong percentage naging error. For example, yung data natin is the from year 2000 to 2020 forecast. We have here the actual demand and the forecasted demand. So, ang gagawin lang natin, error analysis, 21 task period. 21 task period. So, copy lang natin yung data. So, the year, the actual forecast, the actual demand, and the forecasted demand, and then we have to click solve. Lalabas. And our error measures, we have the mean absolute percent error is 1%. Standard error is 2,127.086 mean squared error, the MAD, and the mean error. So, you can also check the graph. Ay, lumabas ng graph. The computation. So, yan. Error 1. So, yeah. So we are done with forecasting. Let's move to our next module, which is the game theory. So game theory naman, madalas pinapagawa lang sa atin dito, what is the value of the game? Determine the strategies for player X and Y given the following game. What is the value? Given may strategy si Y, dalawang strategy si X. So, we have the game theory. The number of row and the number of column is 2. For row, 86, 42, 36, and 106. Then, click lang natin solve. The value of the game is 66.7. So, yun. Ganun lang kadali. Isang click lang, malalaman na natin what is the value of the game. Madalas, medyo matagal pa yung solve. So, yun. Next module. EOQ, Economic Order Quantity. We're going to determine the number of quantity na economically maganda for the business. Okay. So we have here the problem. Re Satellite Emporium wishes to determine the best order size for its best-selling satellite dish, model TS111. Ray has estimated the annual demand for this model at 1,000 units. His cost to carry one unit is 100 per unit, and he has estimated that each order costs $25 to place. Using the EOQ model, how many should Ray order each time? So, round your answer to the nearest whole number. For this one, meron ng answer which is $22. So, try natin ano lang, counter check with the use of our Pom-Qm. We have here the economic order quantity. So, based on our given problem, there is no reorder point. So, click lang natin si no reorder point. Demand rate or the D. In our problem, D is 1,000. O, yun yung ating annual demand. The setup or ordering cost is $25. The carrying cost is $100. And the unit cost is ilan nakalagay? So, based doon sa given problem kasi natin, walang unit cost na nilagay, so wala na tayong lalagay dito. So, then, click lang natin si solve. Makikita natin the optimal order quantity dito is 22.36 units. So, same answer with our problem. Dito makikita na rin natin yung ating maximum inventory level which is 22.36. Average inventory is 11.18. Orders per period is 44.72. Nandito na rin yung annual setup cost, annual holding cost, total inventory cost. So, yun. Do you have any question? If none, let's proceed to our next module. So for our next module, this one is the production order quantity, back order. So we have here the given problem. Click lang natin si production order quantity. Ito wala pang back order ito. So the demand rate is 48,000. Ordering cost is 1,800. Carrying cost is $50. Daily production rate is 500. Enter days per year is 250. Daily demand, ano nakalagay dito? Try natin gawing for the unit cost, wala din nakalagay. Sige, try natin lagyan na lang ng 50. And the daily demand rate is 100. So, asala nga. So, dapat daw yung daily production, daily demand, demand rate divided by 250 days per year. So, ito pala, sorry. Either of the two yung ilalagay natin pagdating sa production order quantity, either yung days per year or yung daily demand. So, kahit wala tayong malagay sa daily demand, we can solve the problem wherein the optimal production quantity is 2,368.63. And then automatically, nagsosolve na rin dito sa daily demand rate. So, yun. So, ibig sabihin, for us to give the demand on a daily basis, kailangan magkaroon tayo ng production quantity na 2,368.63. And then the production runs per period per year is 20.26 production runs. Okay? So that is the production order quantity. But if you're going to use the production order quantity with back order model, dito hinihingi yung back order cost. So dito meron naman tayong given which is 250. So unit cost natin is 50, same nung kanina, 48,000. ordering cost. $1,800 and the holding cost is $50 per unit. Daily production rate ay 500 units per day. So the optimal production quantity, mas madami tayo kailangan gawin, which is the 2594.70 kasi nagkakaroon tayo ng mga back orders. Okay? Then, let's proceed to our next module. Actually, hanggang dun lang muna tayo sa ano. Saan ba? Dun lang sa location analysis siguro. Tapos yung next na lang na mga modules ay doon sa ating next meeting na lang. Kung matutuloy tayo next meeting. Okay? So let's proceed to our next module, which is the quantity discount example. Ito naman, kinocompute natin dito the discount based on a quantity given, ordered. Okay? Sa module natin, doon tayo kay quantity discount model. And then the number of price range natin based on problem is 3. Click OK. So for the price ranges, for the lower is 0 to 999. Price, demand rate natin is 5,000. Set up or ordering cost is 439. The holding carrying cost is 0.2. So either 0.2, you may enter 20. Based sa problem kasi natin is 20% or 0.2. But for if may cost tayo talagang binigay si problem, inilalagay natin cost. For example, $15. But for our problem today is 20% of the or of 20% of the cost. So we have here the discount. The upper is lower 0 to 999, 1,000 to 199, and 2,000 and over. So for the price, we have here 0%. And then the cost per unit for this range. So we have here, ano para sa ano? Ang cost natin per range ay 5, 4.80 at 4.75. 5, 4.80 and 4.75. So the optimal order quantity is 1,000. The maximum inventory is 1,000. The average inventory is 5. Ibig sabihin, kung tayo ay bibili or tayo ay order at andito yung given na discount model, mas prefer natin ang bumili ng o mag-order ng 1,000 units with $4.8. Ano kasi kung 5,000 naman yung demand rate natin, parang hindi natin kaya talaga, hindi na mas magiging magastos kapag bumili tayo ng more than 2,000. Okay? So we have to choose dun sa 1,000. Optimal order quantity natin. Okay? Next is the ABC analysis. So we have here the ABC analysis wherein we have here the items, product, annual number of items of sold, cost per unit, and the annual usage value. We have here the number of items. Yan ba to? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 products. Item number 1, beds. Isahin lang natin. Office chairs. Dining table. Chairs. Coffee table. Wardrobes. Yes. computer cabinet, ottomans, and cases. To demand, lagay din natin 5,000, 10,000, 700, 1,500, 700, 600, 600, 700, 500, and 600. For the unit price, $80, $20, $50. $20, $40, $40, $30, kulang ata. 30, 30, and so we have here, meron tayo dito mga condition na kung saan percent of dollar volume accounted for by A items and the percent of dollar volume accounted by B items. So, di ba pag sinabi natin A items, ito talaga yung sa ABC analysis, i-determine natin ano yung mga product na A, which is high yung mahal, tapos maliit lang din yung demand. Parang mga ganun, di ba? Depende yan sa problem. Okay, so try natin gawin itong 60% and this one ay 25%. Sabihin yung types, yung C items ay around 15%. Okay, so solve. So dito kaya natin i-determine si beds at si office chair. Sila yung in terms of dollar volume kasi, sila talaga mataas. So, sila yung makukonsider natin na A items. Si B items naman ay si dining table, chairs, and office table. The C items is wardrobe, desk, computer cabinet, ottomans, and bookcases. So, yun. Mas dali natin ma-determine sino yung mga A items, B items, and C items. Next natin ay Kanban computation. Dito determine lang natin ilang Kanban dapat nating i-provide para makapag-deliver tayo on time based on sa usage, based sa lead time, based sa laban ng container. Okay? Okay. So we have here the problem wherein the usage per day is 30, the lead time is 5, the container quantity is 50, and the safety factor is 1. So wala namang safety factor is 1 lang. Wala naman siya magiging halos yung gusto sa magiging solutions natin. Okay. So try natin siyang input sa ating Pom-Qm. We have here the Kanban computation. The Kanban size is to be known. Okay, daily demand natin is 30. Lead time is 5 days. Safety stocks per unit ay wala. Kanban size ay 50. So we have here the number of Kanbans is 3. Sabihin dapat mayroon tayong 3 Kanban. Possible yan ay isa doon sa gumagamit, isa doon sa nagdi-delete, isa doon sa andun sa picking ng area, at yung isa naman ay yung going delivery or nakastock doon sa gagamit ng mga parts. So si Kanban computation, mas ano siya eh, actually gamit na gamit siya sa mga parts delivery. So yung makukompute natin ilang PKs, ilang box yung kailangan natin na umiikot sa ating production, between production and the warehouse. Okay? Hindi lang naman yan. Next problem, next module natin ay job shop scheduling. We have here the date received, production date, and the due date. Kumbaga, merong mga job na dumating sa shop natin. Sino yung unahin natin? So, try natin to. We have here the job shop scheduling. The number of job ay 4. Machine sequencing is the priority po yung ating gagamitin. So, we have here the job 1, date received. Pag ang ilalagay kasi natin dito is the date received is hindi siya yung kunyari araw. Kumbaga, today is 0 day, tomorrow is 1 day, number 1. Tapos, tomorrow sa araw is 2, 3. Kumbaga, number of days yung pagbabasihan natin. So, date received natin based sa problem ay 1. So, date received natin is 1. Tapos, gaya natin sa katagal magagawa, 2 days, 2, 3, 4. So, due date natin, yung 3, sa 4 na yung due date, yung isa ay sa 3. So, in terms of shortest processing time sa method natin, sino yung kailangan, job must be received before the starting date. Job is 1, so starting date natin is job 1. Dapat pareho sa starting date tsaka dun sa ating date received. So, if we're going to solve the problem using our method, which is the shortest processing time, kailangan nating unahing tapusin si job 1, second si job 2, third si job 3, at then fourth si job 4. But, if there are different kinds of method pa tayong gagamitin, we have the first come, first serve. Siyempre, kung sino unang dumating, parang ganito lang din mangyari. 1, 2, 3, 4. Slack. Due date minus the processing time. Una natin si job 3. Kahit sabay-sabay silang dumating, pero una natin si job 3. Second si job 4. Third si job 1. And fourth si job 2. Wherein our utilization is napakababa. 36.67%. Kapag naman earliest due date, lalabas, ang unahin natin si job 3 kasi lumalabas na siya yung due date natin is 3, siya yung kauna-una. And then second, third, and fourth. Kasi pare-parehas ito ng due date. More or minimize the number of late jobs. Iba-iba yan. Depende sa method. Longest processing time. Based dito ang longest processing time natin si job 4. So siya yung unahin natin. Second, si job 3. And then the critical due date today, divide processing time. Unahin pa rin natin si job 3. Same lang siya noong ating due date. Earliest due date. Okay? Next is our linear programming. Yung other module hindi ko nadaanan kasi naman madali lang. Ito lang medyo complicated lang. The learning linear programming, we have here our condition, max 3, cx1 plus 7x2, wherein our constraint is 1x1 plus 0x2 is less than or equal to 16, 2x of 1 plus 3x of 2 is less than or equal to 19, 1x of 1 plus 1x of 2 is less than 8, wherein x of 1 is x of 2 is more than or equal to 0. So let's try to input yung ating data doon sa ating software. We have here the linear programming. The number of constraints is 1, 2, 3, 4, 5. Kasi si x of 1 is x of 2, dapat magkahiwalay. So we have 5 constraints. And our objective is maximize. The number of variable is 2, the x of 1 and the x of 2. Okay. Maximize natin 5x1 and 7. First constraint, 1, 0, less than or equal to 16. Constraint 2, 2, 3, less than or equal to 19. Constraint 3, 1, 1, less than or equal to 8. Constraint 4, si x sub 1 is greater than or equal to 0. Si x sub 2 is greater than or equal to 0. Lalabas yung equation horns natin is nandito siya. This is the maximum, and our constraint. Okay? Then we have to click solve. Our solution is for x sub 1, we have 5, and for x sub 2, ay 3, wherein our max z is 46. Madali lang. Kung dati, gagawa pa tayo dyan ng, limot ko na, algebraic equation, addition, basta. Medyo mahirap. So ito, medyo madala. Andito rin yung ranging, solutions list, and ito yung mga iteration na ginawa. Kung gagawin natin siya ng manual yan, medyo mahirap pa. So, and the graph na ayaw magpakita. Kaya pa kayo pang mag-ito ng graph. Dito naman, ayan. So, lumalabas, this is our optimal solution. Ito yung graph natin. Nagpagal. Okay. For our next module. Okay, last na. Location analysis. So for the location analysis, same lang siya kanina ng factor rating. So, ito yung problem natin. Using the following factor ratings, determine which location alternative should be chosen on the basis of maximum composite scores, A, B, or C. So we have here the factors. Then the location. Doon tayo muna kay weighting method. Number of factors natin ay 1, 2, 3, 4, 5, 6. And the number of location ay 3. So we have here the convenience. Parking facilities. Display area. Shopper traffic. Kulang pala yung aking 6 pala. 6. Sorry. Okay. Hindi ko na nalagay. Hindi natin nalagay ito. Wait na lang. 0.15. 0.2. 0.18. 0.27. 0.1. 0.1. So we have 80, 70, 60, 72, 76, 92, 88, 90, 90, 94, 86, 80, 88, 90, 82, 96, 85, 75. Then, click lang natin si solve. Lalabas na yung weighted average, which is, we have to choose the location. So, login nyo na ako. Okay? So, yung iba, next na lang natin discuss. Wala pa rin naman data yung iba. Next meeting na lang natin siya i-discuss. Okay? So, that is the first part of our Pom-Qm. Another good thing dito kay Pom-Qm is you can save yung data, yung ginawa mo. File. And then, save as Excel file. Or kung ayaw mo naman ng Excel file, meron dito mga, save mo siya as Pom-Qm na application. So here, convert. Bagal lang. Yan. So once ma-convert natin siya kay Excel file, ito na yung lalabas. This file was created for Pom-Qm for so possible for our activities, ganito yung gagawin natin. I-convert natin siya sa file or pwede rin naman natin gawin ay snip natin yung file na to. So, depende. Okay? So, that is the first part of our Pom-Qm. Do you have any question? So, kung wala na, pwede bang mag-request ako to open your camera, guys? Para lang meron tayo picture. Nga pala, may subject na kayo for next sem? May subject na kayo for next sem? Wala pa? Kasi hindi ko rin alam kung anong year tuturuan ko next sem eh. Anyway. Okay, sige. Screenshot lang natin. 1, 2, 3. Wait lang. Isa pa. Okay. Sige. Thank you. Yun lang naman. So, mamaya, 1 p.m. for our Industrial Information System. See you. Session ko na lang mamaya yun. Okay? Thank you, guys. Bye-bye. Thank you, everyone.
Thank you, sir.
Thank you.
Thank you po.
Thank you.
Yes, sir.
Hi, thank you.